again, my name is Andres and this video is part of the Zero project. Today we'll be talking about hydrogen again. In today's video we'll focus on how to store hydrogen. In the last video we briefly mentioned that hydrogen has a problem. It has low density and it takes a lot of space to store it. However, there are three common ways used nowadays to store hydrogen that solve this space problem. The first method is compressed hydrogen. Hydrogen at atmospheric pressure is a gas, meaning it is a compressible fluid. This means that you can compress the fluid to force the molecules together to occupy less space for the same amount of molecules. This means at high pressures you increase the density of the gas. However, to hold this pressure you need strong tanks. Compressed hydrogen has many applications. For example, hydrogen cars. In hydrogen cars you compress hydrogen at 700 bars. 700 bars is a lot. It's about 700 the atmospheric pressure of Earth. Tanks are still strong, but to make them lighter, they're made of lightweight composite materials. In 700 bars, you can store approximately 400 times more hydrogen than atmospheric pressure. The second method is liquid hydrogen. To liquefy hydrogen, you need cryogenic temperatures. You need to bring down the temperature of hydrogen down to minus 253 degrees Celsius. This will reduce a lot the volume of the hydrogen. However, it will require a lot of energy to bring down the temperature. Usually it's about 30% of the energy stored in the hydrogen. You will need to use it just to cool down the temperature to make it a liquid. Additionally, you would also need extra energy to maintain the temperature so low. The advantage of this method is that you require no pressure, no high pressure like in compressed hydrogen, which is a lot safer. However, the method is complex and inefficient, meaning it's only used for very specific applications, such as rocket fuel for spaceships. Liquid hydrogen can store up to twice as much hydrogen in the same amount of volume than compressed hydrogen at 700 bars. The third method are metal hydrides. Metal hydrides are specific alloys with special properties that will allow for hydrogen molecules to be absorbed in between the gaps of the metal atoms. This is a reversible process, so it will allow for hydrogen to be absorbed inside the metal alloy and for hydrogen to be released for them to be used. The metal alloy is usually grinded down to a fine powder to increase the surface area exposed and therefore improve the rate at which hydrogen can be absorbed inside the metal alloy. The metal alloy is usually sealed inside a tank that will hold the hydrogen in place. Due to the dynamics of the reaction, the metal hydride will get hot when it's being refilled with more hydrogen, and it will get cold when the hydrogen is being used up from inside the metal hydride. I will now show you an example of a metal hydride. This is a metal hydride tank. They can store even more hydrogen than compressed hydrogen or liquid hydrogen. They can actually store twice as much in the same amount of space as liquid hydrogen. The good thing about metal hydrides is that they do not require high amounts of pressure. Neither they require a constant energy consumption such as liquid hydrogen needs. The downside of them is that they're filled with metallic powder to the top, meaning they're heavy and they're not suitable for some application, such as cars. They will be too heavy for the car to move them. They are used in stationary applications, such as a large hydrogen facility to store a large amount of hydrogen in a small space. It can also be stored in small amounts, such as this one. This could be used for a small portable application, such as a hydrogen bike, where you don't need much hydrogen. So overall, which one of the three methods is the best? Compressed hydrogen, liquid hydrogen, or metal hydride? Well, it actually depends on the type of application you want to use, the location where you want to use the hydrogen, and the available space you have to store the hydrogen. And then after you store, you will use the hydrogen. But to use the hydrogen, we will talk that in another video.